Hello, we've got a little bit more histogram notes today. We're going to talk about it's 11.3 day 2 and start with just some interpreting kind of practice with looking at histograms, answering some questions about them. And so the first problem we're going to do here is just looking at this histogram about test scores on a recent physics test. And we're supposed to determine if the statements are true, false, or we don't have enough information. So 15 students are in the class. All right. Well, in a histogram, often we actually can determine how many data points we have because that is represented by the height of each of these bars. And so I can look and see that there's one student in that one, this one, because its height is at 2. There's 2, 4, 5, 2, and 1. And so we can add up and see that we have, let's see, that's 3 and 9 is 12, 13, 14, 15. So that is a true statement. There are 15 students in the class. B says more students earned a 40 to 59 than a 60 to 69. So this we just have to look. Let's see, 40 to 59 would be there, so that's 3 students. 60 to 69 is just this one right there, but that's 4 students. So more students earned 40 to 59. That's false because that was only 3 compared to 4. More students earned 70 to 79 than any other 10% interval. That's right there. That's 5. That is definitely the highest bar in our histogram, so that is true. The range of test scores is 60. Okay. So looking at the histogram, it seems like they're doing 100 minus 40 to get that range of 60, which could potentially be true if the highest score is 100 and the lowest score is 40, but we don't actually know that. We only know that the highest score is somewhere between 90 and 100. So this one, it's not false necessarily because we don't know. It's not enough information. And in E, the average test score was 70. That's another one. We just don't have enough information. A histogram doesn't tell us the mean test score. All right, let's take a look at number 2. This one's about the number of siblings in a group of students. So I don't know what happened with all these extra gray bars going across here, but we've got how many siblings did they have, and how many students had that number of siblings. Okay, so one thing before we get looking at this, so we can see this first bin is 0 to 2, and then 2 to 4, and then 4 to 6. But often, so we were going to say, like, you can't have 1.5 siblings, so this bin is really covering how many people had 0 or 1 siblings. Usually for a histogram, like the left side of the rectangle is included in that one. So for 2, it's on the border of both, right? So it's usually included in the one that comes after. So this is going to be 2 and 3 siblings, and this last one would be 4 and 5 siblings. So for part A, what is the width of each bin? Well, technically it's 2. 2 siblings wide. And how many students took the survey? Well, once again, we can kind of count based on the heights. So that's 11. This one, it's 7. And let's see, that's 3. So 10, 11 is 21. We had 21 students. How many students have 2 or more siblings? Okay, so that's going to be from 2 onward, so that would be 7 plus 3 is 10. How many students have 6 siblings? So based on this, we actually can say 0 if you think about it, because looking at our pattern here, the first bar was for 0 and 1, and then 2 and 3, and then 4 and 5, which means 6 and 7 go in that next bar there, and there are none in that bar, so we can say 0. And which bin is the median in? That's an interesting question that we like to ask when we're talking about histograms, because we actually can figure out, we don't know exactly what the median is, but we can figure out what bin it's located in based on the fact that we know there's 21 students. So when you find a median, remember you're finding the middle data point. And if there's 21 students, we can think of splitting 21 up into a group of 10 students and a group of 10 students, and there'd be one in the middle, right? That's how we would find the median. It would be the 11th student. Why the 11th? Because if I were counting out my data points, to get to the very middle one, I would need to count 10, and then that next student would be the middle data point, because then I would count 10 more, and I would have all 21. So the 11th student would be the median. And if I look at my histogram, I can see where the 11th student is. The 11th student, there are 11 students in the first bin. So the 11th student would be a number between 0 and 2, basically. So the first bin is where the median is. Okay, and if you think about it, it's because this bin has 11 students in it. And so I'd have to make a list of, there's probably, let's say maybe there were 7 students with 0 siblings and 4 students with 1 sibling. And so your list would have 0, 0, 0, 0, all 7 zeros and 4 ones. That fourth one would be the middle number of the whole data set. That's why we know for a fact the median is in this bin. All right, number 3 here. Why don't you pause it and try to answer these 2 questions on your own. Part B is just like what we just did. Okay, let's see how you did. So how many different people were surveyed? I count 20 surveyed. And then which bin does the median fall? Well, that means I've got, if I were going to split this in half, I'd have 10 and I'd have 10. And there wouldn't be a middle number, so to find the median, it's going to be, I'd have to count 10 people on each side. So let's see. I'm going to mark these in orange here as I go. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is between those 2. We don't know for sure which bin it would be in, and so we could say between 20 and 30. Okay. And I guess that's not really a bin, so we would either say either 20 to 25 or 25 to 30 is where the median has to be. All right, we're going to move on to the next page here. And on the back, we see this histogram about the cost of various Michael Kors items. And we have a bunch of information about it, the mean, the standard deviation, and the 5-number summary. So describe the shape. We talked about the shape yesterday, and if I look at this, I see that tail off to the right. So we would say that the shape is skewed right. Okay, what does this shape tell us in general about the cost of Michael Kors items? Well, what that means is, that means more of our data is at the lower cost items. Okay, there's a lot more data there. That's why the bins are higher there than all of those. So we say more of the items are in the lower price ranges. Describe the center. Well, we talked about if it's a skewed data set, we want to use the median to describe the center because the mean is impacted too much by outliers. And so we would say the median price is, and then you look up here, $70. $70. What does the center tell you in general? It tells us, so it's a median, so we know that 50% of the items cost less than $70. The spread. So when we talk about the spread, if it's skewed, we use median for center, we use IQR for spread. So we're going to say IQR equals, and then it's Q3 minus Q1. So we would say 92.5 minus 47.5, which is, let's see, $45. Okay, that's the IQR, that's describing the spread. What does it tell us? All right, it tells us that the middle 50% of items is spread out by $45. It's like the range of the middle 50%. What is the outlier? There's definitely an outlier, right? And so if we go back up and look at our chart, we can see that there's this one item, and we know it's one based on the frequency, that costs a big amount. And normally a histogram doesn't tell us that, but we actually have the max right there. So we can say that the outlier is the item that costs $215. And what does it tell you in general about the cost of Michael Kors items? So this one I think is talking about kind of the whole, the stats of this distribution. And so what is it saying in general? Well, it kind of tells us that a typical, when we talk about the median being 70, we say a typical item costs around $70, right? And but the items are pretty spread out. Like that IQR is $45, so that's a pretty big range there for the middle 50%. So, but the prices are pretty spread out, including an outlier of $215. So that's kind of how you would approach a problem like that. It's, again, a little bit subjective in your descriptions, but we want to use that pattern of symmetric mean standard deviation or skewed median IQR. Thanks.